So, very good morning to you all. So, welcome to the fifth session of overview of geoprocessing using Python. So, actually, yesterday we discussed about how do we read raster data using GDAL. So, just a quick recap. It was like irrespective of the underlying format, maybe GeoTIFF, IMG, or any other format, so the GDAL represents entire image as a data set. So data set will in turn will contain different bands plus projection and geotransformation information, and the bands will contain data, and maybe there may be some overviews associated with each band. So how do we read an image? Just we have to call the function gdal.open. So gdal.open, and there we need to pass the name of the file. Then then from that data set we can fetch an individual band or all bands together depending on our requirement. Then the same data can be visualized as well. So then suppose if you have to read a multi-dimensional raster like maybe HDF or netcdf format, for that actually then there is a function like once you read a data set, then you will be getting sub data sets. So from that sub data set you need to fetch individual bands. That was the case of multi-dimensional raster, maybe like HDF or netcdf. So now today we will discuss about how do we write raster image using GDAL. So first we will see that how do we write a single band raster. Then subsequently we will see how can we write a multi-band raster using GDAL. So basically actually there are two ways to create a raster using GDAL. So one is called a create copy method. So one is create copy and another is create. So the create copy method involves calling create copy method on the format driver and passing in a source dataset that could be copied. So create copy is useful when suppose now you have already an image available with you that is also already available in nets like you say GeoTIFF or IMG format on, and you just want to read that data and do some processing on that data and write it back to the disk. So it means that when you have a source data available with you in the similar format and same thing you want to write it back, so the create copy method is useful there. While create method is that is like explicitly like when you don't have already available your data in GeoTIFF format directly, like you have some other format and just you want to read that data and write into the TIFF or some other format. So there the create method will be helpful. So with the actually when you are using create copy method, so everything gets copied from the source file. So like its projection information, transformation, or everything is copied there. Then you can do some modification on the data and then you can write back. But in case of create method, this is just like you need to create that, like everything you need to set, like right from transformation, projection, data, everything you need to set while creating the format. So actually GDAL supports multiple drivers, multiple formats. So there's like so if you want to know about the details, this is the link available. You can go to this link and see that which all formats are supported by GDAL. So let us see that how do we write a raster using a create copy method. So like suppose for that suppose I want to create a GeoTIFF image. So for that I am defining a variable called file format is equal to GTIFF. Actually for every format there are short names for the format, so that you can refer to this link. So if you see for these all the formats, these are the short names. Like for GeoTIFF, so GeoTIFF this is the short name is GTIFF. So this name only you need to use while creating the driver for that particular format, like grass, GTIFF. So then like if you want to create an ADAS image in IMG file, so for that the format short name is HFA. So you need to refer to this documentation and accordingly make the format name. So file format like because I want to create a GeoTIFF image, so I have I am assigning to the variable format name gtif. So then first thing actually what happens, for every format there will be a separate driver, because the underlying data structure will be different for each of the formats. So for handling every format we need to create a driver. So with the, while how do we create a driver, we need to call this jidal dot get driver by name. So by calling this method we are creating a driver for handling that particular format. So depending on the format you need to create the driver. So like suppose if you are now anyway we are going to create a handle, we are going to create a GeoTIFF format. So we have created a method like I am calling jidal dot get driver by name, and here I am passing the file format variable. So this creates a driver. So once the driver is created, like suppose if I want, there are multiple methods available on this function available on this driver. Like suppose I want to know the short name of the driver. So it says gtif. Like similar way you can get like driver dot long name. So it says geotiff. And like suppose if you want to know what all metadata this driver supports, so then you can call driver dot get metadata and metadata. If you see, then this shows the metadata about the data, like whether it supports create. So what all functions this particular driver supports. So it says like it supports create, copy, open, raster, virtual IO. So these are the different metadata available with this driver, like options. So basically you can see like whether your driver supports creating and create, copy, open or not. So with this we can say that like, okay, this particular driver is supporting both the function create as well as create, copy. So both you can create a new data set as well, or you can copy from an existing data set also. This particular driver, GeoTIFF driver, is supporting both of these formats. So now let us see how do we use this. Now once the driver is created, so now then next we need to call the create copy method on the driver. So create copy method is fairly simple, as most of the information is collected from the source data set, because here we have all the information available right from the projection, transformation data, everything, and all, even some metadata also available in the source data set. So everything will be copied from the source data set, and later on we can do some modification and write. Right now here, now in my folder I have this file name L3 NH44N07. This is some list 3 band 4 image available in my system. So right now I'll show you my folder. C drive and RMS, and inside this Nainital I have this file band4.tif. This particular file is there. So now what I will do, I will copy everything from this file and do some processing on that data, and we will write back this to another file called, here we are calling it output raster 1 is already existing here. So I will just delete this file. So it is already open in Python, so I will just delete it from here. I'm just restarting the kernel. So as I have just restarted the kernel, so I need to just rerun all the code once again. So I will be running So now here I have defined a variable called source file. So from this file 9may19 band4.tif, 9may19 band4.tif. So this is my source file. So I will be copying this file and doing some modification on this data and writing it back. So I have created source file variable name, then destination file name, like this file I want to copy to this output raster1.tiff image. So now first thing is I have to open my source file so that I can copy everything from it. So like first I will be open this file. I will be opening this file for reading. So I'll say this is I'm calling source dataset src_ds equal to jidal.open source file. So I am first opening the source file for copying. And similar thing like first I am creating a driver for handling this particular format. So driver jidal.get driver by name gtiff. Then I need to call on this driver create copy method. So driver dot create copy. So it takes two argument. One is your destination file name, to which file you want to copy this data, destination file name, and next is source data set. So actually destination could be a file name, but source must be a data set. So source data set is our, we have opened the source file in src_ds. So if I do this, we can say now here that everything from the source dataset has been copied to this dst_ds variable. So this dst_ds is same as our source_dataset. Now suppose let us see how the data looks in our source file. So now I am just reading source dataset dot read as array. So I am just trying to read all the data from my source dataset and storing in a variable data. Now this is the data available. Now suppose if I see this data, okay, now these are like this. Now suppose I want to do some processing on this data, maybe like clipping some values or doing some operation, finding some pixels with certain values and so on. So we can do now, because this is a numpy array. So now you can do any operation which you can do on the two-dimensional matrix. Same thing can be applied here. Now here what we are doing, I am just inverting the data, right? All ones I am making zeros and zeros I am making ones. So it is like if some portion of the image that is black will become white and some portion of the image that is white will become black. So I am just inverting the data. So that I will store in a variable called inverted data. So this is the function available for this np.invert. So np.invert, like if you see the computes the bitwise inversion or bitwise not of the underlying data. So with this I am converting all ones to zeros in the image and zeros to one. So this will be my inverted data. Now let us visualize these data and inverted data together. Then later on we will write this inverted data to our destination data set. Like so, same thing, I am creating a figure of size say 15 by 5. Then I am calling plt.subplots. So one row and two columns. Then in that I am first plotting the data and inverted data, and with the same color map, gray color map. So now if you see these two images together here, so this is the original data and this is the inverted data. So here you can see that this is the Nainital lake. So this was shown in black, complete black in this, but in this case it is showing as, is being shown as completely bright. So we have inverted. So all the areas which were black, so one spot you can see here is converted to the completely bright, and these black areas are converted to white, bright areas, and bright areas, whatever areas were bright in this image, these have been turned into the dark areas. So this way now we have just inverted the image. Now suppose if you want to write this inverted data to our destination data set. So the same thing is like, first we need to fetch that particular band from our destination data set, because we had already created destination data set. So I am fetching the band 1, because we want to write this data to the band 1 only. So destination data set dot get raster band. So I am interested in fetching the band 1. So that value I am storing in this output band or out band, you can say. And like while for reading the data from the band, the method was out underscore like band dot read as array. So for writing the data, the function is write array. So out underscore band dot write array. Then what data you want to write to that. So I am writing inverted data. So once this data is done, then you need to call this flush cache method. Actually what happens, suppose if you are running a code and if you don't call this flush cache method, so what the operating system does not immediately write the data to the disk. So now suppose if you have executed this piece of code, and just if you are trying to open the file, you may see sometimes just black only, because operating system has not written back it to the disk, because operating system will for optimization purpose, it may club the data from multiple sources, and then only it may write after some time for the because of the performance. So suppose if you want to force operating system to write that data to the disk, then you need to call this flush cache. So with the flush cache, we are forcing the operating system to write back the data to the disk. Then once this is done, for freeing the resources, you need to delete this destination data set. Right, so now this way I have deleted the data. Now if I see in this directory, a file with name OP raster 1 must have been created. So you can see that OP raster 1 is created at 11:21. So this is the latest file. So now this file can be visualized. So now let us see how does this data looks like, because our now let's try to read it using GDAL again. So like same thing like GDAL dot open. Now this destination file name, because we have written the data to the destination file name, is already OP raster 1. So I am just trying to open this file and let us see the data. So let's plot it. So if you plot it this way, you can see that. So this way you can use create copy method for, like suppose if you want to do some processing on your existing data, and same data you want to so we want to do some modification on the data and write it back. So then GDA create copy method is the most suitable for this purpose. So now let us see now how to write a raster using a function, a create method. For the situations in which we are not just exporting an existing file to a new file, it is generally necessary to use create method. Okay, the create method needs because in this create copy time, everything was available in the source data, so everything was getting copied from the source. But when you are using create method, you need to define like image size, what is the width and height of your data, how many bands are there in your image, and type of the pixel intensity, like you want to write the pixel intensity in pixel, a floating point number, integer, or a complex number depending on your requirement. So you need to specify these things for using the create method: image size, number of image size in terms of width and height, number of bands, and data type of pixel intensity. Okay, now for this we have a here I have a CSV file with name rainfall. So if I will show you here rainfall, so I have a CSV file here with the name rainfall. So this is the description of this data. So this is a CSV file containing daily gridded rainfall data set over the entire India. So here we have some rainfall data of entire India. This is a gridded rainfall data set only. Gridded rainfall containing covering all over the India. So the first data set in the record, so the entire data starts from 66.5 degree north and 66.5 degree east. So the location of this first pixel is 6.5 degree north and 66.5 degree east, and the resolution in the x direction, or you can say resolution in the x direction, is 0.25 degree, and similar way in the resolution in y direction also is 0.25 degree. So like suppose if you refer to this next entry, so this will be 6.5 degree north and 66.75 degree east, because in x direction we are going by 0.25 degree, and if you refer to this will be in y direction, it will be increased by 0.25 degrees, so it will be 6.75 degree north. So you can assume that we have a gridded data of the entire India. So the lat long of this 00 pixel are 6.5 degree north and 66.5 degree east, and the resolution in x direction is 0.25 degree, and the resolution in y direction also is 2.5 degree. So if you calculate over this, so the last data record corresponds to 38.5 degree north and 100 degree east. So the total extent of our data is 6.5 degree north and 66.5 degree east to 38.5 degree north and 100 degree east. So this is, so totally there are 129 rows and 135 columns in this text file. Now let us see how do we convert this CSV or text file to a GeoTIFF or maybe IMG format. So here output raster 2. So output raster 2 doesn't exist here. Okay, it doesn't exist. So first what I am calling, I am just creating a variable called source text file. In this I am saving the name of this file rainfall.txt, and this same file after converting into GeoTIFF I will be writing into the op raster2.tiff. So like now the process is similar. First we need to create a driver. So for that gdal.getDriver by name, so gtiff. Now on this driver we need to call create method. Instead of calling the create copy, here we are using create method. So driver.create. So we need to pass is the following argument, like first is the destination file name, to which file you want to store your data. So destination file name, then your X size or width of your image, Y size, height of image, because in our original data there are 135 columns and 129 rows. So X size is 135, Y size is 129. So actually these you can pass, because here we are assuming it to be static only, but you can make it programmable as well. So, but before creating the driver, before calling this create method, you must know these width and height of your image, so that you can get it somehow programmatically. So X size, Y size, then we are telling that it has single band because just rainfall data is available, so number of bands to be 1. Then E type is like a data type, like how do you want to store this data. So anyway, this looks like floating point data or floating point number. So instead of unsigned 16, integer 16, we'll call it float. So gdal.gdt. So float, like suppose if you want to store it in a 32-bit precision, float 32, or suppose double precision, float 64 also we can do it. So once this is, so we'll call it 32 or 64 anyway. So once this is done, so destination data set is created. So ds, if I ds underscore dst, so destination data set dst underscore ds. So destination data set got created. Now for writing to this, I need to get the data. So the data is available in this source text file, right? So for that I need to read first this text file and get data from this text file. So because this is a CSV file, for this I am using for reading this file, there are multiple ways to read it, but anyway, because I need an NumPy array, so I am directly reading it using NumPy. So in NumPy there is a function available called load text. So load txt reads an CSV file. So I am calling this np.load.txt. So here I need to pass different arguments. One is your data file name, from which file you want to read the data. So source text file, then delimiters in your text file. So because this is a CSV file, so all the entries are separated by a comma. So I am passing a delimiter as comma. Then data type, like how to interpret the value in particular cell, because these are floating point numbers. We want it to be interpreted as a 64-bit floating point number or double precision floating point number. So if I call this entire text file will be read, and the data will be assigned to a NumPy 2-dimensional NumPy array. So if I see the data, so it looks like this. So now you can see that this all we have read, this entire file we have read as an NumPy array. Right, now we need to write this data to our destination data set. So for that, because we have created a single band raster, so I am fetching the first band from my destination data set. So band is equal to destination data set dot get raster band. So now we have fetched the band. Now what happens when somebody creates a data set or a DOT file, they will attach some metadata also with the data, so that the consumer of the data knows about the data. So some attributes of the data you can store in metadata as well, like who created, when created, processing level, and some auxiliary information. Suppose if you want to supply it with your data, that is generally supplied in the form of metadata. So now let us suppose we want to write some metadata also with this data. So for that, first we need to create some metadata. Like right now, suppose if you just want to add some like date, time, like when this file was produced, suppose in the date metadata, we just wanted to write that information only. So for that, we need to create a dictionary. So dictionary will be as explained in my first lecture. So dictionary is a set of key value pairs. So like here I am creating a dictionary called band meta. So there are like, this is key value pairs. So like an attribute is like date of creation. So I am creating an attribute in this date of creation. In that I am just writing the date time now, what is present date time, and maybe like scale factor of 1, and this way you can attach many more metadata to your band. So I have created a dictionary. Now this band meta, if I see, so it looks like this. So date of creation and scale factor. Now suppose this data I want to attach to my band. So in that band there is a function called set metadata. So actually you must take care of these cases. So S is capital and M is also capital. So band dot set metadata, and pass it the dictionary of your key value pairs. So band dot set metadata. So this way now I have set the metadata also to the band. Now as you can see this, like these 99.0, there are a lot of 99.00s in this data set. So these minus 999s represent missing data or no data. So for these points there is no rainfall data available as for. So suppose if you want to set the no data also to a raster, then you can call on that band set no data value. You can call this method or function set no data value. So band dot set no data value minus 999. So this sets the no data value to be minus 999. So once all these things are done, now we can just write back this data to the band. So band dot write array, instead of reading, band dot write array data. So now all the data and metadata has been written to this particular band. Now there may be like, suppose if your image may contain multiple bands. So then there may be like, suppose you want to, it may be the requirement also that you have written metadata to separate it to each band, and there may be some common metadata that is applicable to the all bands together. So that information also can be written, so that metadata you can write at dataset level itself. So on the individual band you can write separate data metadata by calling that band dot set metadata. Then plus you can write like some metadata that may be applicable to all bands together. So that metadata you can write on the dataset itself also. Like here also we are creating a dictionary, same thing, similar way, like your date of creation and like organization or processing level, something, because processing level of all the bands will be similar, and maybe some common metadata you want to write to all bands, so that can be written to the dataset level as well. So like here I have called a variable, created a dictionary called ds meta, and now instead of there we have called this set metadata on the band. So now here we will call that directly on the destination or dataset. So destination dataset dot set metadata. This way we can write. So here we have written two levels of metadata. One metadata that is at the dataset level. So that may be common to the entire image, common to all bands, and we can write the metadata specific to that band as well by calling this set metadata function either on the band or dataset itself. So once this all is done, now we have written dataset at the metadata at the dataset level as well as on the band level, and we have written the data also to that band. Now everything is done. Now the same thing, like we will flush the cache and delete this dataset. So either we can like write dst underscore ds equal to none, or we can say del dst underscore ds. So flush cache and this. Now if I see here, you will see that there must be a file with name op raster2. op raster2 is Nothing is written as of now. Nothing got written here. Okay, let us see it again. Now let us try to read this file. So now anyway it is not showing just now, but the data got written here. Copy raster to where is that OP? So it says like anyway this is not displaying, or now it is showing. So 192 KB data is got written on this file, copy raster 2. Now let us read this using GDAL directly. So like here I have given the ds equal to GDAL.open destination file name, and if I want to fetch the metadata, so this function get metadata. There we were calling set metadata. Now get metadata. So these were this data set. See we had written this data metadata to the data set like date of creation, organization, and processing level. So we are able to fetch it back. Similar way, now, like suppose if you want to fetch the metadata which we had written to that band, that also support if you want to fetch. So then we can call ds dot get raster band 1 and then get metadata on this. So here also we had written like this two attributes we had written, date of creation and scale factor. So this way we are able to fetch the metadata. Now suppose let us see whether we are able to fetch the no data value on that particular band. So ds dot get raster band 1 then dot get no data value. So if we see we had set the -999 as the no data value, so we are able to fetch it back. Now let us see how does this data looks like. So for this actually we are using another package in NumPy called masked array. So what is happening here, because there will be a lot of more. So okay, let us see first without this masked array. So I am just reading the data, and suppose if I plot this data, so this data looks like this. So these are all the places where, because we had set -19 -99, so these all values are -999. So only because of this we are able to see this. Now suppose if you want to mask out these -999s so that we can see these rainfall data in much detail. So for that we need to use another package called masked array. In NumPy there is a package numpy.ma, that is masked array. So here suppose if you want to mask all the values all the pixels where the value is -99, because the -999 because these are missing values. So for that there is a package called masked array. So I am here calling data is equal to ds.read as array. Then I am masking this data by calling this ma.masked equal. So in the data wherever value is -999, so those pixels we are going to mask with this. So these pixels will not be used anywhere. So for any calculation or just for displaying as well. So these pixels will be masked. So this way we can mask any pixel. So ma.masked equal. So wherever the value of pixel is -999, so those pixels are getting masked. So now if I plot this data, then you will see the difference. So now you can see that these all areas got masked, and a little more detail we are able to see this. So the rainfall is varying from 0 to 200 mm. So entire India, so this region is getting more rainfall on that particular day, or these regions have less rainfall. So actually here if you see that I have passed one more argument to this IMSO function, this is origin is equal to lower. So now if I don't pass this, you will see this to be an up down manner, because if generally what happens, this top left pixel will have this suppose if I see this image, so this 0th pixel will be on the top, and in the y direction we will see the resolution in negative. So this will be 0, but in our original text image, in our text file, what is happening, this latitude is increasing, so the image is like this. So we need to flip, for showing it correctly we need to flip it, because the origin is at this level, lower. So for this we are passing the another argument to is that origin is equal to lower. So because 0 in our image, 0 is at this level, so for showing the image correctly we need to flip it upside down. So this way, by origin lower, we can see the image. So this way we can convert any CSV data which is in graded format or to the any raster format, maybe like GOT, IMG or any other format. So if you remember one more thing, that in this data, like suppose if you open this OP raster 2 with any other GIS software, so you may see that it will report another like projection information is missing. So it will not be able to project this data on the map, because we have not written any like projection and transformation information to the image. So image is without any projection information. So let us see how do we create a geo-referenced image using GDAL. Right. So for that we need to use another package called OSR. OSR is for spatial reference. So first I need to import this OSR from the OSGeo. So now for this, suppose if you want to create an spatial reference or projection system first, then we will write this projection information to the image as well. So for that, first you need to call this OSR.spatial reference. So it creates an spatial reference system. On this, now we want to set whether, so because we want to create a geographic coordinate system. So actually for some well-known geographic coordinate system, there is a function available, set well-known GeoGCS. So suppose if you want to set it to be the GeoGCS of EPSG 4326, so then directly we can call it CRS.set well-known GeoGCS, WGS84. So with this we are creating a WGS84 geographic coordinate system. And let us see that how does this it looks like. Now if I convert it to the WKT format like this CRS, I am exporting it to the WKT format for seeing its description. So this is the description of this geographic coordinate system which we have created. So this is GeoGCS with WGS84 datum, and these are the semi-major axis and other parameters of this projection system. Now once we have created a projection system, now we need to write transformation information also associated with the image. Like if you remember, as I said that the latitude and longitude of 00th pixel are 66.5 degree east and 6.5 degree north. So these values we have written here, like a longitude of 00th pixel, then a resolution in x direction, because the image grid size was 0.25 degree. So 0.25 degree, then north is directly up in our image, so there is no rotation, so 0. Then latitude of the 00th pixel 6.5, then rotation is 0, so north up. Then resolution in y direction also is 0.25. So the resolution, so in y direction also resolution is increasing. So the image is, you can say that is upside down. So in generally, if you remember in previous cases, we were seeing this resolution in y direction to be minus, because this 00th pixel starts from here and goes to this. But in our case, what is happening, even 00 case is starting from this top down, and in y direction it is going to this direction. So 00 is at the lower bottom, or left bottom left corner. So here the resolution is 0.25 degree. So now this is the transformation information. Now same thing like source text file and output raster 2 we are creating. Now this time we are going to write it in IMG format. So IMG or ADAS IMG format. So if anything is there here, OP raster 2, I will delete it. So it is not available, looks like. To TIFF only is there, so IMG is not there. So I have created a source text file and then destination file. Now the other things are same only. Only thing that when creating a driver, GDAL.get driver by name HFA. So instead of GOT, I am passing it the name to be HFA because now we want to create an IMG image or ADAS image in format. So now next thing is same like destination dataset driver.create, destination file name, X size, Y size, number of bands and data type. Data type is float 32. Float 32. Then now with the destination dataset, because we want to create a geo-referenced image, so we need to set projection as well as geo transformation. So like for reading the projection information, the function was get projection. For writing the projection, set projection. Destination dataset dot set projection. Now this CRS, because this particular function set projection takes projection information only in WKT format. So we are converting this CRS, exporting this CRS to WKT format. So CRS dot export to WKT. This way we are setting the projection. So similar to this, we can set the geo transformation. So destination dataset dot set geo transform. With this we are setting the geo transformation information. Like now will fetch the individual band like band 1. Same thing, only here extra information we have written these two, projection and transformation information. Get raster band, then set data value -99.00. Then now we are reading the data from the image and just write that data to the destination data or band. Then destination or the band, also you can call the flush cache on the band. Band dot flush cache and destination. So this way now we will see that output raster 2.tiff must have been created here. .img, sorry. So our output raster 2.img got created here. Okay. Now let us try to read this file and fetch the projection information from this. So this says that this is the projection information what we had written. The same thing we are able to read it back. Then transformation information. So these are 6, this whatever we had set. And now suppose if you want to see the data as well, then you can see data as well. So now because these are shown in the different color, so for that we need to create a masked array. So once this is done, we can delete it. Now similar to this, now we have created an image. Now suppose if you want to do some optimizations on the image, right? Now suppose if you want to write this image as a tiled image. So for fast image exploration and serving, so generally when your image gets served by a web server or geospatial web server, we can say that if you write the image in a tiled format, so the image can be written in blockwise and the exploration of the image will be exploration and serving on the web will be faster. So for fast image exploration and serving, we generally want to tile the raster so that requesting a small window in it only needs accessing that modest amount of data. So when we are going to write image in a tiled format and suppose some of the client wants to access some small portion of the data. So instead of reading the entire image and clipping that portion, so if the image will be in the tiled format, so the web server can just read that small modest amount of data and serve it back. So the serving will be faster. Now suppose if you want to write this particular image in a tiled format, so now there are functions like same thing we'll be doing, like source file is our nainital.tiff. And same thing, suppose Nainital, if I want to write in a tiled format. So I will call destination file as nani_tiled.tiff. Now the other things remain same. Like first we need to create a driver. Then anyway we are using the create copy method. So I am opening the source file. Then in the destination, while creating the destination dataset, driver.create copy. Then destination file name. So and then source dataset, and then another argument we can pass to the create copy method like options. So now I want to write this file as a tiled image. So for that I am passing it arguments like options. So options in this, options will be a list. So here I am passing an argument called tiled is equal to yes. So with this, what will happen when writing the file? This will be written in tiled format. So now if I see this Jidal info nainital.tif may not be required. Now if you see naini.tif, nainital.tif and naini.tif. Underscore tiled. So if you see this, so now you can see that if I show you nainital.tif, so nainital.tif, if you see here, the block size is 115 by 1. But once we write in the tiled format, so the image will be written in the small tiles of 256 by 256. So here if you see, the block size is 256 by 256. So this way you can see that this has written in this image got written in the tiled format. So similar way there are other optimization options, like suppose if you want to write image in a compressed format. So generally, and there are compression can again be lossless or lossy compression. Suppose if you want to write image in using some lossless compression. So on fast computers, reading from the storage might be a bottleneck. So compression can, with compression you can gain a big you can gain in performance. So there are multiple algorithms for lossless compression. Like there is this is the one of the most commonly used algorithm is deflate. Now suppose if you have a large image and you want to write you want to compress the image using deflate algorithm. So all the things are same only, like suppose our source file is nainital.tif and now we want to write it using nainital underscore lzw. Like LZW compression is used in deflate algorithm, lzw.tif. Then other things are same only, like driver.create, source dataset, create copy. And here we need to pass another argument like compression is equal to. So their first argument was, actually these all you can combine multiple options as well. Like if suppose if you want to compress it using LZW compression, LZW. If you want to compress it using deflate, you can pass it like deflate. So later on you can see this image as well. Like if I say Jidal.info, is my destination file name. Somewhere it must be showing like compression driver. So this function is not showing. So right, this Jidal info is not showing, but if you open it with some software, this here it is showing lzw.tif. So compression it is not showing, but when you read it with some other software, or maybe when you read in detail, it will show the which compression is being used. So similar way, suppose if you want to use some lossy compression like JPEG or something, so then you can say in the options you can write compression JPEG and quality like what compression ratio you want to store. So this way you can store store in using different compression algorithms. Then suppose if you want to write overviews also with your image, like for fast zoom out operations, we may want to provide overviews. So generally overview factors are specified as successive power of 2's. One can consider, like suppose it can go from native resolution to up to 256 by 256. So the entire image will be covered into 256 pixels. So that way in the successive power of 2, like suppose originally our image was 1200 by 1200. So first overview will be at 600 by 600, then 300 by 300, then 256 by 256. So this way, suppose if you want to create overviews of your image also, then same thing like create copy, and then you can call this function build overviews. So you want to create averages and at this level 2, 4, 8, 16. So the pixel resolution will get like here suppose originally pixel resolution was 1 kilometer. Then the first overview will be created at 500 2 kilometers, 4 kilometers, 8 kilometers, and this way we can create different overviews as well. So now suppose now in the GDAL there is another utility called, or suppose if you want to convert from one raster format to other raster format. So there is a utility in GDAL called GDAL translate. So with the help of GDAL translate, you can convert to different raster formats. Like suppose if you have TIFF image and you want it converted to the IMG format, or you have IMG format you want to convert to TIFF, and or so on. Or so for that there is a utility called GDAL translate. Let us see how do we use this GDAL translate utility for converting different raster formats. Now like here I have created a source file nainital.tif. Now suppose if I want to convert it into IMG format. So the format is quite simple. Like I need to call this function GDAL.translate. So GDAL.translate actually takes multiple arguments. So you can refer to the documentation for more details. So anyway, by default I am passing it only just 2 arguments, like my destination file name and source file name. So because I want to from TIFF I want to convert it to IMG format. So I am just calling GDAL.translate naini.img and my source file name. So with this, if you see, my file gets converted to the IMG format. If I see here, one file with naini.img must have been got created here. So naini.img, a file got created here. So this way, with using GDAL translate, you can convert to any raster format. And there are multiple options also. Now suppose if you want to create like width percentage, so width you want to reduce by 50%, like number of pixels you want to reduce in your image by 50%. So you can pass another argument to this, like width percentage, height percentage. So with this you will see that the image size gets halved. So if you see this, so here you can see this, there are multiple options: width percentage, height percentage, then you can clip to certain regions and so on. So there are multiple options available with GDAL translate. You can subset your image. Like here we are just making it 50% of the original image. So this way you can do this. So there are multiple options available with GDAL translate. Those you can explore. So similar thing, like suppose if you want to reorder the bands in your image. So in nainital.tif, now suppose there were 4 bands. Now out of these 4 bands, I want to fetch only band 2, 3 and 4 and want to rearrange, like 4th band I want to put in place of 1st band, 3rd band I want to put in place of 2nd band, and so on. So suppose if I want to reorder the bands of my image, so that also can be done using GDAL translate. Like I can call this GDAL.translate, like I am calling it rgb_reorder.tif, my nainital.tif file, and I am just fetching band 2, 3 and 4. So now band 2 will go at band 1, 3rd band will go at band 2 and 4th band will go at band 3. Then like create options, I can pass like different create option what we are passing, like tiled, you want it to be tiled, compressed or photometric. So photometric means that band 1 will be to be interpreted as R, 2 2 to be interpreted as G, and 3 to be interpreted as B. So this way I can reorder the bands. Now suppose if I see this image and see this way I can reorder the bands in any order. Like I have an already image, so that I can reorder these bands. So if I see this JDAL info, because we have written it as photometric is equal to RGB. Now if you will see the interpretation of bands, must be written like band 1 color interpretation is red, because we have written photometric is equal to RGB. So color interpretation red, band 2 to be interpreted as green, and band 3 to be interpreted as blue. So this way we can, using JDAL. So this was, so with this we come to the end of this lecture. So just a quick review. So this was, we covered like how do we write rasters using one method called create, another method create copy, and with JDAL translate how can we convert to different formats. And later on we saw that like how do we write the color interpretation to the image, and we can optimize the image for writing, like suppose if you are like compressing the image, writing a tiled image, or like different options, like suppose if your image size is more than 4 GB, so then GOT format may not be sufficient. Then suppose if you want to write in big TIFF format, so that also you can specify in these options. So this was all about today's lecture. So thank you very much. If you have any questions, you can please post it on the chat box. I will be happy to answer. Thank you very much. We'll come back after 2 minutes.